Today's notes are on modeling quadratic functions. Remember that if the a value is greater than 0, the parabola opens up, which means that the vertex will have a minimum value. And if the value of a is less than 0, the parabola opens down and the vertex becomes a maximum value. For these problems, we are going to round all of our answers to the nearest hundredth. For example 1, it says, given the equation y equals 3x squared plus 7x minus 5, use your graphing calculator to sketch a graph of the equation and then find the following. Right, so to do this, you are going to plug this into your y equals. And then hit graph. You should see a picture of the graph, so drawing a sketch of it. It should look something like this. Part A asks us to find the vertex and then state whether or not it is a maximum or a minimum. So looking at the picture, we should know that it's a minimum because it's the lowest point. If you want to calculate that value, you're going to hit second trace, which gets you to the calculate key. And then you're going to select the option that says max min. It should then, when you hit enter, it should come up on your calculator asking you for a left bound. So you'll take your orb until it is somewhere to the left of the lowest point, and you want to be safely to the left of the lowest point, so up here somewhere is fine. You'll hit enter. It'll then ask you for the right bound. So you do the same thing. Move the cursor until it is clearly to the right of the vertex, and then you're going to hit enter twice. At the bottom of your screen, you should see that x is equal to negative 1.17 and y is equal to negative 9.08. That gives us the ordered pair of our vertex. Next, it asks us to find the x-intercepts. So we're going to go back to the same screen. So you're going to use calculate, so second trace. And this time we're going to be solving for the zeros. And you are going to be solving for two x-intercepts, one here and one here. And it does not matter which one you look at first. So if I look at the point on the left first, after you select zeros, it's going to ask you for left bound. So here's the area that's clearly to the left of my point. If you're not sure which side is to the left and to the right, move your cursor until it's close to the point and then use the left arrow key to move in the correct direction. Once you have the left bound put in, select enter and move your point to the right of the intercept and select enter twice. That will give you your first intercept, which should be negative 2.91, 0. Then I want to repeat the whole thing with the second point. So second trace to get to the calculate, select zeros. This time my left bound is below the line. Again, get your cursor as close as you can to the point and then use the left arrow to decide what's the left bound. Hit enter, then move up to the right bound and hit enter twice. You should see the ordered pair. .57, 0. The last thing it wants us to find for this problem is the y-intercept. So we're going to go back into calculate. And this time we're going to select value. When you hit enter at the bottom of your screen, you should see an x equals pop up. Because I'm trying to find the y-intercept, that means the x value is always equal to 0. So if I take x equals 0, hit enter, it should tell me that my ordered pair is 0, -5. Part A, you could do without a graphing calculator if you use our formula for finding the vertex in standard form, x equals -b over 2a. We haven't yet covered how to find the intercepts when a quadratic is in standard form, so you would not be able to do B without your graphing calculator. But C you could find by simply plugging in 0 for all the x's and solving for y. For example 2, it wants us to find the solutions of the equation by using the graphing calculator again. So if I put this equation into my y equals and clear the other one out, and I'm going to sketch a picture. It asks me to find the solutions, which are the same as the intercepts or the zeros. So we're going to hit calculate and go down to zeros. And I'm going to do the same thing where I have to go through it twice to find the one on the left and on the right. Because it's asking us to find the zeros and not the intercepts, we do not have to write our answer as an ordered pair. So we can simply say the answer is -1.3 and 2.3. Please take a look at example 3 on the next page. We're going to go through again and use our graphing calculator to help us solve example 3. It says the path of the rabbit's jump is given by the equation -1/3 x squared plus 6 over 5x, where x is the horizontal distance in feet and y is the height in feet. So knowing that this is my x-axis, I know that this is going to represent my distance. And that's going to be measured in feet. And it said the y was going to be the height in feet. So when it tells you to label your axes, this is what it means. So step A, sketch a graph of the rabbit's path and label your axes. So you're going to use your calculator, plug the equation into y equals, and hit graph for a picture. Notice that in this graph, the parabola goes through the point 0, 0. You want to make sure that you include that in your sketch. Then it asks us for the rabbit's maximum height. So we're going to use calculate, and I'm calculating the maximum. And I want to go ahead and find the left bound and the right bound. It gives me the ordered pair 1.8 and 1.08. Because it's asking me for the height, that's the y value, so the rabbit's height was 1.08 feet. Next, it asked me how far had the rabbit traveled horizontally at its maximum height. Well, now it wants our distance, which is our x. So without having to calculate anything else, I know that at the vertex it had traveled 1.8 feet. That is our horizontal distance for this question. The last thing it asks us to find is how far from her original position did the rabbit land. So 0, 0 is where I start. I haven't traveled at all, horizontally or vertically. Then I jump up, 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 and I know that I land when I have a height of 0. I can't have a negative height because it's impossible for me to go through and underneath the ground. So in order to calculate that point, that was one of our zeros. So we go to calculate and then down to 0, which should give us the answer 3.60. And this is again labeled in feet. And in case you didn't see the laser, we saw our rabbit go up and back down. This is the point here where it lands. Please try and do example 4 on your own. If you don't have a graphing calculator, at least write in what you're calculating, the 0, a value, a maximum or minimum, and see if you can answer some of the questions. We will go through that one together tomorrow in class.